First one from online, we've got a question from Tulu about how we're actually, as users, doing that fine-tuning with something like ChatGPT.
That's a good question.
Does it rely on us saying, I didn't like that answer, or is it simply the use of it and mass use that is doing that process?
That is a very good question. So the way it's done is, of course, now, if you use GPT extensively, sometimes it will give you two answers and will ask you, which one do you prefer? Mm-hmm. And you can't move on till you actually click on the one that you prefer. This is ingenious. So they're getting free data from us, just like that. Before they go to this stage, though, they got actual humans. And the actual humans were paid money to decide. And this is quite a costly process, and you need to anticipate all the user needs. And as we saw here with a few examples, the user needs are vast. You're asking questions from poems to fact-based things to I don't know what. And that's why when people say, oh, the technology, it cannot learn on its own. It needs the signal. And the signal is given either by an expert with demonstrations or by us naive users who do the simple thing of actually stating our preferences. Sometimes it also asks you, did you like the answer? And you can just say yes or no.
Yeah, go for it.
Hi, I'm Vanessa. Thanks so much for a really interesting talk. So my question is about building a language model, but particularly in situations where so you said that we need sort of a large bank of information, and for languages like English, French, German, we've got lots.
That's a very good question. Yeah.
But in the case of rare or dead languages, where we have less to split into test and training data, how do we work around and still get correct information?
This is a perfect question, and the answer is that there is no workaround, in the sense that these things take all of the language of the world, but some languages are underrepresented. And for those languages, and this is a question, is it fair? Who benefits? It will be worse. Now, there is some fixes that you can do. For example, try to give it some more targeted data. So there is a universe where you get all these speakers of these underrepresented languages, and you get data and you fine-tune more, but there will always be a disadvantage, as well as, I would argue, the users of the technology of these languages, because there will be always less stuff for them. And it's something that as a society we need to somehow address. I also don't see, to be completely honest, in underdeveloped nations, suddenly being spin-offs and companies there that will pay all this money to train these models. And so we have like this inequality now that starts even universities versus companies and goes into the society, and this is a very good question.
Right, we're going to have to come back to capitalism, aren't we? But just to be clear, no, it's good. Like, we really do have to come back to capitalism. But the point here is not just underrepresented languages, but languages where there's less money to be made from engaging with the people who speak them.
Of course, yes.
Yeah, very good. In white, thank you.
Is it on, yeah? Yeah. Thank you so much for your talk. That was really interesting. I might have an annoyingly specific question. I work for a company that works to reduce mis and disinformation online. We do this in a variety of methods, whether that be fact-checking, open source intelligence investigations, and we actually also have our own AI-powered threat detection platform. I work in government relations. I am not the data scientist who engages with this is just my boyfriend uses this to write my birthday cards. I really don't engage with these platforms myself.
You guys been together long?
But my day-to-day consists of speaking to MPs or speaking to members of the European Parliament, etc., and talking about gaps in legislation whereby we could see the danger of bad actors looking to use these kind of large language models to produce disinformation campaigns. And what I found most striking from this presentation is you used the examples of, not making offensive jokes about women or the response about dictators. This has kind of turned all of my assumptions on its head insofar as I was under the impression that these are tools that are very easy to be used by bad actors in this way, and that there was very little content moderation applied.
No, they do that because,
Can I just ask you one question before you get? What do you hear from the policymakers? I mean, what are they interested in? Where are they at with this?
It depends who you talk to, doesn't
Okay,
it? It depends on
right.
the political party. For the most part, if we're talking about the public, like actual elected MPs and MEPs, they're extremely worried. I think specifically with the UK's general election, really due to take place before January 2025, the fact that the online safety bill, I don't mean to alarm anyone, but it kind of doesn't matter that it got passed because the election's happening before it even comes into force. So any of the protections that we could get from that, the election doesn't benefit from those. And so there is quite a concern, particularly from my company's perspective, on where these disinformation campaigns might be maliciously impacting those electoral processes.
Okay, super interesting. Thank you. Please.
So I do think that we will develop tools that will detect whether something has been generated by an AI tool or a human. For example, I don't want to get very technical, but you can actually tell by looking at how the thing is generated, whether it's on words or subwords, and subwords indicates transformers rather than words, which indicates people. So there are ways of
When you say you can tell, you don't mean that you yourself as a human can do that. You can build a machine that will tell.
You can build a computer, and in fact, Google recently they launched a tool that can tell you whether an image has been generated by AI, and they do it. It's very clever, and you cannot tell. It's not watermarked. So we will get there. Now, the point of misinformation, fine, GPT actually can do these things, but you can also fool it. So if I say, write a text about MP so-and-so, I don't know whether it has been trained. It could be that it says, I'm not allowed to do that, if it knows that this MP is like an important person. But it could be for somebody that we don't know. If they haven't thought of this eventuality, I mean, they cannot think of everything. They are doing a good job with all these humans. So I think there is a worry, but there is an election, there is misinformation. Would a human doing this be different than the AI? Because we do, there's fake reviews, there is a lot of conspiracy theories on the web. The problem with AI, of course, is that it can go, you can go viral. Yeah.
Okay, thank you. Alana, how are we doing online with this?
So that talk of concern about how do we manage this and mitigate problems is something that everyone's kind of really getting engaged with online. And one thing we're thinking about, if they're scraping the internet, if they're scraping all text, how does it know if something is false at that point? And how do we look at that? And then if we're using something like a large language model, we had one question from Andrew about if it's used in medical diagnoses, if we've got this hallucinatory problem, how do we then determine that it's not, feeding in that point? So, lots of chat about how do we know?
Right. So the first question is how can we get rid of fake information on the web? We can't. There is no way to regulate it. You download the thing on some supercomputer, and then you just start churning data. So you cannot avoid, there will be fake information there. And all you can do is sort of mitigate once you generate. Mm-hmm.
Just to be clear on that, though, the question specifically is, can you not run a tool to label false stuff before it gets ingested by the model?
How would you know whether it's impossible?
I don't know,
it is, all you can do, so you can generate and propagate misinformation, and you can be, theories and whatever. They deal with that somehow in their fine-tuning so that it cannot, like the obvious things, it cannot spout, inaccuracies. Now, there was a second question, which is about the medical diagnosis.
Medical and hallucination, yeah.
Hallucinations are a problem. If it outputs things and, life is at risk, you cannot deploy it unless it is 100%. You cannot lie, you cannot say things that are not there. My impression is that when these things are used with doctors and whatnot, there is always, and we should always have an expert in the room who can tell this is true or not. I think also these models, again, you can think of how there will be classifiers that they train them so that, you can learn whether you are truthful or not. You do the fact-checking as part of the training. We're not there yet, but what I can tell you is that GPT-4, which is the most advanced version, it's 80% accurate. They've done these experiments. Previous versions hallucinated a lot more. This is a very hard problem, and you can understand why you cannot regulate it, because the whole thing is trained on the basis of likelihood. You predict a likely outcome, not a real one. Because that's what the language modeling is doing. So we need another process to get rid of this. Yes, okay, finished.
There you go. Listen, come
No,
on.
I mean, next question.
No, you're doing great. It's just like you want to come back on that?
Just very quickly,
Okay.
because we do have a question from Aidan about that training and how if ChatGPT was trained on Stack Overflow, but now that programmers are just going straight to ChatGPT and they're not using those systems that trained it in the first place, do we then get to a point where its training source material dries up? You know, how do we ensure that?
Yes, this will happen. I can tell you. I've heard last time that they're actually taking all these movies and they are transcribing the audio so that they can use more data. This will happen eventually. And then, I don't know, we have to actually go to the drawing board, back to the drawing board, and be a bit more clever, because we're being a bit complacent. This language model can do a lot of things. And we're behaving like, technology is over, NLP is dead. You stop doing anything, just fine-tune and fine-tune. So we have to think of clever ways of actually dealing with this data problem. One idea would be, if we are very good at these generative models, they could generate the code for us and go and train, and it's a vicious circle then. But yeah.
So we need to keep making stuff as humans. By the way, guys, we're going to have to speed up, only because there's so many questions. Let's go there.
Hi. Thank you very much for the talk. It was very lovely.
Where are you? I cannot.
In the white, just there. Yep.
So I really wanted to hear your opinions on the labor aspect behind all of this. Largely the fact that obviously it's trained at this point on the entirety of the corpus of the internet, and we accept that. But moving on from this point, different companies and startups have been trying to find really expert opinions so that we can continue to fine-tune these processes, and they're paying out of pocket for them. And on top of that, I wanted to hear about what you think about us indirectly training these models through things like capture. I'm not sure if people have realized, but we're now training AI-generated content on captures. So I was hoping you'd speak a bit on that.
Yeah, that's a very good question. So it doesn't work very well without the humans, without the fine-tuning of the humans, and without, first of all, they actually come up with scenarios, all these usage cases, and they write gold standard answers. Gold standard means what an ideal answer. Right. So first they fine-tune on that, and then they do the preferences. I skipped this on the talk because it would have been too much. So the humans are very critical in this process, and I don't see getting rid of them quite soon.
We won't be eliminated because we're still useful to make the AIs better.
Because you cannot think maybe tomorrow I want like some weird thing that nobody has thought of. Now, the training, you raised a very good point, and it is it is there. It is there. The problem is that it is not so sophisticated. So you can train for simple tasks, and they do it. And also, for Google it happens, and it has been happening forever. You click on the things, and then they exploit it, and then they go and they do the preferences. The same with Facebook and whatnot. But this is the easy stuff. For generating the content and coming up with things that make sense is not so easy. Okay. And that's why the humans are there.
Okay,
yeah.
Still good. Right, in salmon, I think, first, and then in black next. I'm going colours. It's also really dark up there, so if it's not salmon, I apologise.
Is there any work on creating better computer architecture for AIs? Because humans are very good, and biological creatures are very good at having very efficient connectors. Right. You had the example of an ant, which in the microscopic size had the same power as a supercomputer and same number of parameters. Is there any more? Yeah.
That is a perfect question. It's a very good
question. Our
question.
Audience, right?
They're amazing. These are the best questions I've had.
Listen, come again.
So this is a very good question, and you'd think there would be more work. Right now, everybody's using these transformers because they kind of work. There is some work in making them smaller. So, because we all understand that this is not sustainable, the money, the energy, the whatnot. So, there is work on doing the same thing, but with less. And there is some new architectures there, making the parameters and whatnot. Before the transformers, there was quite a bit of work on convolutional neural networks. This is another philosophy of how you create neural networks. all dead, honestly. But I don't see how we can go forward without going backwards and doing these new architectures. So this is the future,
Okay,
I
and
think.
biologically inspired architectures particularly. Should we just do next to you as well in the chat? Okay, or we're all good. Okay, great. So we're going here next. Thanks.
Yes, right here.
Oh, hello.
Right here. My question is on this notion of emergent properties. So Professor Ethan Mollick, for example, at Wharton says because GPT-4 can identify novel metaphors, it seems to be evidence of a mental model. Stanford has issued a paper asserting theory of mind. Stephen Wolfram has talked about emergent properties in the neural networks. What's your take on?
Yeah,
So just to be clear, what do you mean by an emergent property?
The idea that there is reasoning capability that goes beyond just simple statistical next word prediction.
Okay, so the question is really whether what's going on inside its mind,
is it sort
and
of
is there
thinking?
anything like
Yeah.
the kind of things that are going on inside our mind? Do you really need the slides? Because we can come back to them if you would. Yeah.
No, I don't need the slides.
It's for you.
So,
Okay, cool.
So the emergent properties have been touted as like, this is amazing because now it can do the things that it hasn't explicitly seen. But my thinking, and there is literature to this effect, is that these emergent properties are really the effect of more fine-tuning. They don't call it fine-tuning, but they call it demonstrations, they call it instructions. So if you do the controlled experiment where you remove the instructions, and you see, if you remove the instructions, the properties are not there anymore. So it is very clever.
Yeah.
It
so
is very.
It's coming from us then. This
Well,
sense?
yeah, because somebody thought, okay, I will give it instructions, and the instructions are like things that people ask in a clever way. So the human has actually coded this way of operating, and we've given it the emergent properties. So the same with chain of thought reasoning. I don't know whether you're familiar. You asked me a technical question, so you're going to get the technical answer. So chain of thought reasoning, it can do chain of thought
What's
reasoning.
chain of thought reasoning?
So you ask a question, and you say, how can I multiply 3 by 5? And then you say, let's do it step by step. Okay. You take the number 3, then you take the number 5. 3 times 5 gives you, so you sort of do the reasoning step by step. So now, why is this impressive? It's impressive because it can do it, whatever, but we've given it examples of this. So and the examples are some form of fine-tuning. It's not like the full thing where you have to actually change all the weights, but you are softly changing parameters. So this is not so impressive. I mean, it's impressive it can do it, but yeah.
Okay, good. And we had a cloud there. Yeah, there's in black with the hand just a little further in front of you than you are. One row down, and yeah, there you go. And then we'll come to the...
Hi, I just have a little question. How does it deal with things like words that are similar? So like when it's being trained, if you say something is grey or it's a light black, like how does it deal with
That's a very good question.
Synonyms?
Right. So it learns that they're similar because in theory, this is a very good question. How does it know that they are equivalent? Remember, it has the context, and these things tend to appear in similar contexts. So we will refer to a coat as gray or light black. So it infers that things that appear in similar contexts tend to be similar. And the beauty of neural networks is that it learns this. And so these two words that you said would have similar weights. And that's all it knows. It's all numbers and weights. And it's not very sophisticated, but it works much better than actually just, trying to find out the similarity by looking at a dictionary, which a human would have written.
But there's a sense in which it knows what color is. I mean, like it knows dark black and gray, but does it have semantic or conceptual knowledge?
It would have to be grounded in the real world. So
Yep.
to know
and is
what
it?
is... No, because it hasn't seen images.
Okay.
ChatGPT has not seen images. So it does not do this grounding. And that's why this is another good point as to how these things will become like humans and super intelligent. Humans are emerged in the environment where they actually touch and feel and smell and, all of these things. It doesn't have intent, it doesn't have emotions, and it cannot know color. It can simulate it knows. Right?
And still, by the way, that's how people are doing, like do we feel better when we find out things it can't do, or do we feel worse when we find out things it can't do? Alana, how does the internet feel?
Or just on that emotions.
Where are you? There is
Alana's
one
just
coming
here.
in.
She's representing the entire
you're there.
online chat.
I
Sorry.
am the internet for
It's a
tonight.
light.
By the way, in case you're wondering, it's not like she's got all these amazing ideas. She's getting them from the live chat. Yeah, exactly. She does also have amazing ideas.
Maybe it's all ChatGPT. No. So on that emotions thing, we've got one comment from Russ who was talking about the fact that the future, he believes, with humanity is that we're going to focus on connection, on art, on those feelings of creativity, and then AI is going to be that thing that is helping us be human.
Yes.
But on the question front, just going back to transformers, so if all the blocks in a transformer are in a series, we've got one question from Gauss, is why not simply have one single large neural network with many layers rather than breaking it up into many blocks? So that structure, how does that help with that process?
Okay, so the question is, why don't you have one big monolithic thing than little things that are whatever? Yeah, so so you have to understand that a lot of how we build things and how we do them, it's empirical science. It's like we don't have a recipe. We found a recipe that works well. So a discovery that was made is that if you stack blocks on top of each other, so you go from the input to some level and another level and another level, the more you go up, you learn more general things. So you may, in the beginning, know things just about words. Then you learn things about similar words. Then you learn things about syntax, like about how we put words together. Then, after you learn about syntax, you can actually learn about longer context, like paragraphs. So it does things bits by bits, and this stacking helps with generalization and with learning. That's a sort of answer that I can give you without getting too technical. And that we know, we've actually done the tests. Some layers in the transformer represent syntax, others represent semantics, and yeah.
I think we have something in pink. Yes, there we go. That works.
Hi, it's actually a question about bias. So there's obviously a bias in the source data that's coming in and how to manage that. But it's also, how do you manage any of the bias in the fine-tuning if it's done by humans?
Yes, that's a good question. And the bias in the fine-tuning is done, so once you've pre-trained the thing, you cannot manage the bias on its own. So it would say, I don't know, women are stupid and whatnot. Then you have to do the extra layer of doing the preferences. And in the preferences, you would output something that is clearly biased and something that isn't. And the human is instructed, always pick the non-biased. So you have to actually give it data that tells it, prefer the non-biased solution. Also, do not take a stance, all of these things. And that we do it for Western culture, but I do not know what happens in other cultures. Because there was a question there, a very good question. What do we do? The same with the genders and everything. What do we do in other cultures? And will they fine-tune it for some...
One quick question on the bias thing, though, as a follow-up. So the literature on the bias in humans is depressing, right? We all have it. And it's even more depressing because we can't fix it, right? So the bias detection tools that you can try, the Harvard implicit association task and stuff, shows you're racist. And the people who made the tool have proved that you can't fix that. All you can do is like blind recruitment or stuff to work around your own biases. People would say the advantage of AIs is that even they have bias because they're trained on data sets that we produced and are therefore biased, we can debias the AIs, unlike people. Would you agree to that with that statement?
I think we can debias the AI with training.
Okay.
But I would say that we would need very many cases of debiasing, because bias happens everywhere. There is a, recruitment, there is auditions, there is the color, everything.
All right, we'll score one for AI. Yes, thank you for patience.
Hi, my name is Kostal. Will continuing to increase these model sizes on and on and on eventually lead to AGI, or will it need a number of different breakthroughs to eventually get there?
Remind us what AGI stands for?
Artificial Generative Intelligence.
Or general. General, which is like, so it can do anything, not just the things that it's asked to. Sorry, I didn't mean to put you.
So general means that we have one computer that can do everything like a human. And my answer to this is, I think the models will get smaller rather than bigger. There's already a tendency, GPT-4, for example, is smaller than ChatGPT. They get smaller in terms of size because, of course, they get fine-tuned, so in some sense, not cheaper. Whether we can have general intelligence in the future, I think that will be not so easy, because right now what we do is we get impressed with GPT, and then we ask questions and follow-on questions, and we are the intelligence admiring GPT. And we say, oh, it can do planning, it can do this, it can do chain of thought reasoning. In fact, we are giving all the examples. To do artificial intelligence that is very general, we would need to go back and think. There was a question up there about the architecture. The architecture is very inefficient right now. And unfortunately, with this kind of inefficiency, and we do only text, imagine now if we have to emulate the human in the real world. We have vision, we have sound, we have affordances. You know, if I bump my hand there, it may hurt, and all of these things. So imagine putting all of that. It is not scalable.
So do we feel better knowing that she doesn't think it's going to reach AGI?
I mean,
Does it
there may
feel
be
worse?
NVIDIA computers that will do it. I don't know, but there's years ahead.
We'll go last
That's all
word
I'm
from
saying.
the internet, one behind you, and then we're probably done.
So one thing the internet is
Where
talking about
are
is
you?
me.
Where
It's
are you?
internet
She's still
again.
at the front, still in the live chat.
The lights!
I
know.
Okay, say.
I might move for next time. No. So one thing that the internet world is also talking about is AI detection. So someone's talking about how would an organisation know if you were applying for a job and using a tool like ChatGPT, and the detection software that we're using is another form of AI.
Oh,
so
God.
you know how
Okay.
So a nice easy one to end on, but just you know that almost
question.
reverse process of identifying whether something is human generated, AI generated, are those just assumptions based on the same kind of modeling, and can we trust that?
Yes. Okay. So to actually identifying whether something has been generated by AI or not, it's a simple classifier. You don't need ChatGPT. You don't need all these large-scale things. You just need some data where a human has annotated yes or no. And you could even do it in terms of length. There are some surface-style features that you could apply to identify this. So this is a far easier task than actually building the big model. Whether it's circular, yes. Yes, I cannot deny this, but there is a lot of AI that we don't see and we don't know about, and it helps us. And in that case, if it helps us not spam the internet with untruths, I would say it will be okay. Yeah.
Very good. Brief final question, yes.
Brilliantly explained. Thank you
Too
very
kind.
much.
Too kind.
I'm from the age before computers literally had slide scales. This is a brilliant...
So you will actually build the supercomputer everybody's asking about.
This is a brilliant advance. Just because it can, all scientific advances can be used for ill as well as good. But generally, we're making progress. It's a problem for the people in the governance and not the science. What do you think of that?
We could not end on a better note. There it is.
The RI audience, thank you. Before we wrap fully, it gives me enormous pleasure to invite the Alan Turing Institute in the person of Harry Sood to make a couple of concluding remarks. Luckily, there's a microphone right either in front of you or behind you. Thanks, Harry.
Cool, thank you, Daniel. And firstly, a massive round of applause, please, for Mirella. For an awesome talk. Awesome. Thank you very much, Mirella. That was amazing.
Thank you too.
So just a couple of sort of housekeeping-y things to finish. So I'm aware there's like loads more questions, both in person and online. Mirella will be doing a podcast with us in the coming weeks, which will be released on social media and emails, so keep a lookout for that. If you're online, we've got the transcripts. We're going to keep the questions and we'll put them forward in the podcast. If you're in person, there's going to be a feedback form going out afterwards where you can ask those additional questions. So if you didn't get to ask your question today, ask it there, and we'll try and put it in the podcast as well, depending on how many questions there are. If you don't have a question and we've answered everything you want to know about AI today, firstly, there is plenty more to learn, so do keep coming back to these lectures. But also, that feedback form, please do fill it in just so we can know how to improve these events, make them better, and all that kind of stuff going forward into the future. Just after this, we're going to be hanging out outside, packing up. Mirella will be there as well for any questions you want to ask in person. We're doing a sort of a Vox Pop thing, which is a 2-minute sort of interview about how you found today, what you've learned, all that kind of stuff. So we might grab 1 or 2 of you for that as well. And in terms of the next Turing lecture, it will be delivered by ethics fellow and comedian Vari Aitken on the 17th of October, so put it into your calendars now. And she'll be exploring the risks of generative AI and what you need to be aware of, so it's tackling some of those challenges and thorny ethical questions as well. There may be a QR code about it. If
We're
not,
working on the QR
again,
code.
it'll be on our socials and website and emails as well. And just finally, again, on behalf of everyone at the Turing Institute, thank you so much to the Turing Events team for putting this on, to the Royal Institution for hosting. And again, one final round of applause, please, for Professor Mirella.